Hey everyone, Mr. Voikin here. This is lesson 1.11 on statistics, page 39 to 41. And we want to first understand what statistics are and what they are used for. Well, what do we do with statistics? We collect data. So data is just information. So we collect information about something. We call that data. And what do we do with it? Well, we make decisions. It helps us make informed decisions. So for example, say at the school cafeteria, they've got 6 choices. What are they going to serve to the students for the month of September? So what they would do is they would poll or survey and ask students a question like, out of these 6, what would be your favorite 2? Now, all that data is going to be collected. So if we say 60 people chose hamburger and 8 chose fish and chips and 4 chose tuna salad and 75 chose pizza and soup was 58 and spaghetti was 99. Okay, so from this, they're going to basically start to eliminate some because there's obviously not much desire for that, and they're going to choose the top 1, 2, or whatever it happens to be, 3, and that's how they will make their menu. Okay, so this data that we collect, there are going to be 2 different types. So one is going to be discrete, and the other one is going to be continuous. So you need to understand the difference between discrete and continuous. So let's take a look at the definition for discrete. This is data that is collected and it is restricted. So this word is really important right here. It's restricted to certain values. Okay, so that means there are not infinite values within a specific range. So an example of this would be, say, the shoe sizes, the shoe sizes of students. So we're not going to have unlimited shoe sizes. We're going to have numbers like 38, 39, 40, 41, 42, etc. Or if I went around and I asked you to go to all of the classes in the school and determine the average sort of class size, and again, you would go into one class and there was 24 students, or 18 in another, and 25. You know, we can't have 16.2 students. That is just impossible. So these discrete values are going to be sort of defined and restricted to these certain values. So what about continuous? Well, it's sort of the opposite. So we aren't going to be restricted to any value. So basically, there is going to be what we call a range of values. So a specified range, and it can be any value within that range. So an example would be, say we are planting a small little tree in our class, so we want to measure and record the height of the tree. Okay, now we're not going to be doing this all the time. We're going to pick intervals. So maybe I'll start off with the first week, then the second week, then the third week, and then the fourth week. So I'm going to take it 4 different measurements. And when I take these measurements, I get 3 centimeters, followed by 3.3 centimeters, and then 4.8 centimeters, and we'll say 6.1 centimeters. Now, when the tree grew from 3 to 3.3, it didn't just jump to 3.3, it literally hit every range in between 3 and 3.3. So every value that was in between those two was reached at some point. So there could have been a 3.01, a 3.01148, etc. So there's basically an unlimited number of values within a specified range. And this could also be with something like speed. Okay, so the speed of a car as it drove down the street. So it started at 0 kilometers per hour, and after say 15 seconds, it was going 60 kilometers per hour. So basically what happened is in between 0 and 60, again, it hit every possible range, every possible speed in between. So at some point on here, there's a point, and that could be 30.516 kilometers per hour. All right, now you've had a brief introduction to statistics. Let's do an example, okay? Mr. Voikin's class were asked how many hours each day they play on their phone. So we are going to tabulate these results, and the choices are 0, 1, 2, 3, and 4 hours. So we're going to tabulate these by just getting students to come by and sort of put a little tick underneath the number that represents the number of hours they play on the phone. And in the end, it sort of looked like this. And from this, we can gather some information. So first of all, how many students are in the class? The number of students are going to be 6, 7, 10, 22. So we got 22 students in the class. What seems to be the most popular choice? Well, the most popular choice seemed to be 2 hours. And the least popular, well, there was 2 of them. There was 0 and really 4 hours. Okay, but we usually don't leave it in this format. We either put it into a line graph or a bar graph or a pie chart or something like that. So let's take this and quickly put this into a bar graph. Now, in order to make a good bar graph, one, you need to focus on neatness and accuracy, but you need to include some information as well. Okay, so first of all, we're going to sort of have our y-axis going straight up and down, and our x-axis going off to the right like this. Okay, at the top, we're going to have a title. So the title would be number of hours on a phone. Okay, and down below, we got to figure out what are we going to put on the bottom axis and what are we going to put on the left axis. So down here, usually time goes down to the bottom. So this would be number of hours, and over here this would be number of students. Okay, I'll just move that over a little bit, give us a little bit more space. And if we're going to be making a bar graph, we want to take a look at and spread it out evenly. So right here I'm going to have 0, right here I'll have 1, and then 2, and 3, and followed by 4. So going up the y-axis or the vertical axis, we got to take a look at how many sort of spots we have going up. So 1, 2, 3, 4, 5, 6, 7, 8. So if I go up 8, you can see I won't be able to include all this data right here because there's 12 choices. So in this case, I'm going to make every sort of line that we go up is going to be 2. So that'd be 2, 4, 6, 8, 10, 12, and 14. So you usually want to go a little bit past that. So let's take a look at 0. For 0 hours, there was only 1 student. Now we can't go all the way up to the line, so we're just going to go right here halfway, which is going to be right there. So there is 1 student that played on their phone for 0 hours. Now for 1 hour, we had 6 students, and quite often we'll change to another color. So 6 students would be up to this point right here. And 2 hours was 12 students. So again, we'll grab a different color and we'll go all the way up to 12. And 3 hours was 2 students. So again, one more color, we'll choose purple right here. There's the 2 students. And lastly, for 4 hours on the phone, there was only 1 student. So again, we'll fill in this little bar graph right here, and we are finished. All right, let's move on to a second example. So that first one was dealing with number of students. So you can see the data that we collected was discrete. And this one is going to be an example of continuous data. So we're going to be planting a plant in our class and recording the height of that plant over 6 months. Okay, so in September, we measured it and it was 1.3 centimeters. So all of these are going to be centimeters right here. And following that in October, it was 1.8 centimeters. November was 2.5 centimeters. December, it would jump right up to 4.1, and then 4.8, and finally 7.5 centimeters. So once we've collected the data, again, we need to put this into some type of chart so that it can be presented a lot better. And this time we're going to make a line chart. So same thing, I need to start off with my axis going straight up and down and the axis moving over to the right. Okay, and now we have to give it a title. So what is the title of this going to be? Height of classroom plant. Okay, and on the bottom we're going to, that's usually going to be time as well. So this is going to be time, and we need to indicate that it is in months. So up the vertical axis, we're going to have height. And again, it's important that we put the units that it's in, which is going to be centimeters. Okay, so now again, I need to take a look at how many sort of positions do I have moving from here over to the right. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 6 months. So that really makes sense that we're going to space them out every sort of 2 lines. So this first line right here is going to be September. Go over 2 lines. I've got October, November, December, January, and February. So we want to try and use most of the chart space that is given to us. So going up, I'm going to start here at 0. Okay, so no matter what, we're going to be starting at 0. And how many spaces do I have going up? 1, 2, 3, 4, 5, 6, 7, 8 spaces going up. And you can see we're going from 1.3 to 7.5. So 7.5 is our highest, and that fits within the 8 right there. So this one's actually quite easy. Now I don't have to put a number on every line, and sometimes it gets too busy. So it could be like 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and now I'm basically just going to put a dot at each one of those positions. So I'll go right here, grab that color, and in September it was 1.3, so it's right around that position. In October is 1.8, so a little bit taller in that position. November, it was 2.5, so we're going to be right about here. In December, it jumped up to 4.1, and January, 4.8, and in February, it jumped all the way up to 7.5. Now, because this is going to be a line graph, we can actually now take a line and join these points. And there we go. We've got a completed line graph with all of our data plotted. And remember, in between, in these ranges, they're connected with that line because, again, this is continuous data. The tree is continuously growing. Okay, let's move on to our last example here, and we're going to make a pie chart with this one. The question states that students in Mr. Voikin's class or classes were completed a survey about their favorite color. So I have 46 students in both my classes total, and let's just say they came up with, after tabulating the results, 3 like red, 23 like green, 4 like blue, 5 like orange, and 11 like purple. Okay, so what I want to do is I actually want to sort of calculate the percentage of students that like these colors. So what am I going to do? I'm going to take 3 and put it over the total of 46, and then I'm going to multiply that by 100. And I'm going to do 23 over 46, and then multiply that by 100. And I want to do the same all the way down the line. Okay. And that is going to convert this ratio into a percentage. Now, if you do the math, we're going to end up with 6.5% of the students like red, 50% of the students like green, 8.7% of the students like blue, 11% of the students like orange, and 23.8% of the students like purple. Now, these numbers aren't exact, except in the case of green, because 23 over 46 is exactly 50%. The other values have just been rounded to make this total come out to 100%. So if I add all of these together, I should get 100%. So now to make a pie chart, we're going to start off by making a circle. That's not really a circle. Let's try one more time. We're going to start off by making a circle. Beauty. Okay, and then we're going to give it a title. So favorite student colors. Okay, and now what we need to do is we need to sort of split this chart up. And the easiest one to start off with is going to be the green. Because it is 50%, I'm just literally going to sort of split this chart in half right here. Okay, that was a bad line. I'm going to actually make that a little bit thicker and just come straight down like this. Okay, close enough. So essentially over here, I've got this one that we would fill in with green. Okay, now that is going to be, again, 50%, and I need to indicate what this is. So it's green, and it's 50%. Okay, now let's move over to the other one, purple. You can see that it is basically about 25%, which is 1/4. So I would have this shape over here. So right down here, this is going to be colored in purple, and this would be indicated that this is the color purple, and it is 23.8%. Okay, and now we've got those other three. We've got red, green, and orange that need to take up this sort of last little space that we have right in here. Okay, so the largest of those two is going to be orange, which is 11%. So, you know, this in here is representing 25%. So 11 is almost half, a little bit less. So I can see that the orange is going to be a little bit less than half. So maybe something like that. So right here is going to be my orange. And again, I'm going to need an arrow going there indicating that it's orange, and it's at 11%. Okay, we got two colors left. Red is 6.5 and blue is 8.7. So the blue section needs to be slightly bigger than the red one, like that. So here's our blue right there. And again, this one needs to be indicated that it is blue, coming in at 8.7%. And finally, we've got our last little section here that's going to be red, and our red is coming in at 6.5%. All right, so we are at the end of this lesson, and for those of you that finished it quickly or just want to challenge yourself a little bit, I've written down some data here. It doesn't matter what the data represents. We just have numbers 3, 6, 5, 4, 4, 3, 6. So we just need to sort of tabulate these, and we want to do something with these numbers. So besides creating line graphs or bar graphs and pie charts, we can also calculate the range, the mode, the mean, and the median. Now, I haven't gone over how to calculate these four things, but it's really easy for you to go on to the internet and just do a little research on your own and figure it out. Okay, I hope you're successful with that, and we will see you in class.